Okay, so my name is Andre. My group members are Kelsey and Gloria, and today we're going to be going over our hemostasis exercise project. To start, uh, hemostasis is the process of stopping bleeding and helping repair the body after injury. It occurs in three steps: vascular spasms, platelet plug formation, as well as coagulation. So a vascular spasm, it occurs when smooth muscle in the wall of a blood vessel contracts to reduce bleeding. So as you can see on the left here, we have a normal vessel, and then we have a spasmed vessel here contracting to form clots in the vessel. So serotonin and thromboxane A2 contributes to the strength and duration of a vascular spasm.
Alrighty, so next we're introducing the platelet plug formation. So right here is the image of the blood clot formation. So during this process, the platelet aggregation, the platelets stick to exposed collagen fibers in a damaged blood vessel wall with the assistance of von Willebrand factor. The clump now prevents further blood loss. Degranulation of platelets releases chemicals that attract other platelets. Thromboxane A2 stimulates degranulation of other platelets. So as you can see here on the left, we see those platelets starting to accumulate to stop further blood loss. And now we have the coagulation phase. So a fibrin mesh forms a blood clot. And here you see the steps of how that is processed. So the formation of a blood clot or blood coagulation occurs when fibrin proteins become active. Fibrin then traps formed elements and other proteins in a mesh framework, which builds and reinforces the clot. The activation of fibrin depends on numerous clotting factors. And that wraps up the coagulation phase.
Getting into the activation of fibrin, during the coagulation cascade, intrinsic and extrinsic pathways lead to the activation of factor X. Calcium, an important cofactor in the coagulation cascade, activates other clotting factors in both pathways. Factor X activates enzymes that convert soluble fibrinogen to insoluble fibrin. Fibrin will then wrap around a platelet plug to stabilize it and form a blood clot. Getting into a sympathetic nervous system response, this is Kyle. Kyle fell while he was riding his bike and is losing large amounts of blood. Kyle's sympathetic nervous system needs to act fast. In situations where 10% of blood volume is lost, the SNS activates to maintain a stable blood pressure. Vasoconstriction, increased heart rate, increased force of contraction, and redirection of blood flow to the brain and heart all work as part of an SNS response. And with that, Kyle makes a full recovery. Because of the action of his SNS, Kyle was in a stable condition until he could receive medical attention for his injuries. And that concludes our presentation on hemostasis. Okay, is that good?
Mhm.